Okay, dear students, after talking about the cubic root, the fourth root, as well as the square roots, we are going now to talk about the nth roots in general. So we've seen previously a sixth root, we've seen a fifth root, we've seen a seventh root. Now we are going to talk about nth roots, and here are the rules. The first rule says that this is how to represent an nth root. It's denoted by this. So nth root of A, we read it like this: nth root of A times nth root of B is equal to nth root of A times B. That means if they are of the nth roots, the same nth roots, if we have here the same index and we are multiplying them, we can definitely put them under the same nth root multiplied together. So if we have multiplication, and pay attention, not addition or subtraction, multiplication or division, as you see here, we can put them under the same nth root. So nth root of A over nth root of B, B is not 0, is equal to nth root of A over B as well. And finally, nth root of A power n. So as if here I have A to the power 1 and here it is raised to the power n, I can write it as nth root of, so I can write it as nth root of A power n, and by dividing this power by this index, I will get A to the power 1. Now, let's take some examples to make things clear. Let's start by this. Simplify fifth root of 9 times fifth root of 27. So, first of all, I have to decompose the numbers inside into prime factors, powers of prime factors. I will get fifth root of 3 squared times fifth root of 3 cubed. Since I have the same index, I can put them under the same fifth root, and I will get fifth root of 3 squared times 3 cubed, which is fifth root of 3 to the power 5 indeed. That's equal to 3 to the power 1 by dividing this power by this index outside. Fourth root of 32 divided by or over fourth root of 2. I can put them under the same fourth root as follows to get fourth root of 32 divided by 2, and this is where fourth root of 16 come from. Okay, 32 by 2 is 16. Fourth root of 16 is definitely fourth root of 2 to the power 4. Dividing 4 by 4 will get 2 to the power 1. Also, I have here 10th root of 2 to the power 5, all of it raised to the power 2. This exponent 2 has nothing to do with that index. Exponents deal together with each other here. I can multiply 5 times 2. So exponents are multiplied by each other. Then I will get the index at 10. 10th root of 2 to the power 10. Dividing 10 by 10, I get 2. So as if I multiplied 2 times 5. So I will get 10th root of 2 to the power 10, which is 2 as well. Also, I have this example. Cube root of 6 times cube root of 36 is equal to cube root. I decompose 6 into 2 times 3 and 36 into 2 squared times 3 squared. Now, 2 power 2 times 2 power 1 is 2 cubed, and 3 power 2 times 3 power 1 is 3 cubed. So I will get 2 times 3, which is 6. And here I have fourth root of 8 times fourth root of 972. 8 is decomposed into 2 cubed, and this number is decomposed into these. Now 2 cubed times 2 squared is 2 to the power 5. I need 2 to the power 4, so I keep 2 to the power 4 and 2 to the power 1 beside it. Okay, so these give me 2 to the power 5. So these give 2 to the power 5. But since I have the index is equal to 4, I need 2 to the power 4, and I keep, so I decompose 2 power 5 into 2 power 4 times 2 to the power 1. Similarly, for 3 to the power 5, I decompose it into 3 power 4 times 3. Now 2 to the power 4 and 3 to the power 4 can be carried out as 2 times 3. So I will have 2 times 3 and fourth root of 2 times 3, so I will get 6 fourth root of 6. Let's continue to know more and more about nth roots. Note here, if n is even, if the index is even, the index here is even, a and b that are inside must be positives. So if I have a fourth root, a sixth root, an eighth root, a 10th root, a 12th root, whatever, the values inside must be definitely positive. Now, here are rules also concerning nth roots. As I told you, this is called an index, and here the power of a is 1, then definitely nth root of a is a to the power 1 over n. If I have nth root of a to the power 2, then it is a to the power 2 over n, and keep in mind that n is always a natural number starting from 2 till etc. So n is always a natural number. Now, this is in general also. If I have nth root of a power m, as I told you, I just divide the power by the index. I have a to the power m over n, and this is how rational powers appear, why I see fractions in powers. Okay, here is like a note. 8th root of 5 to the power 4 is the same as 5 to the power 4 over 8, which is 5 to the power half. Is the same as 10th root of 5 to the power 5, because it is 5 to the power 5 out of 10, which is 5, 1 over 2, power 1 over 2, which is radical 5. So 8th root of 5 power 4 is equal to 10th root of 5 power 5 is equal to radical 5, and all of them are equal to 5 power half, as well as, for example, if I have 6th root of 5 power 3, this is also 5 to the power half. If I have, for example, a 12th root of 5 to the power 6, also this is equal to 5 to the power 1 over half, 1 over 2, and so on. Now, finally, are more examples. Using nth roots, we have to change to a number with rational exponent. So we have it in the form of an nth root, and we are going to change it as a number with a rational exponent. So as you see here, we have 5th root over 3, then here is 1, 3 power 1, then it is 3 power 1 over 5. It's very easy. It's a very easy idea. So here 4th root of 2 cubed is indeed 2 to the power 3 over 4, and by this we change from nth roots into numbers with rational exponents. Here is an example in terms of x. We have to simplify cube root of x squared times x to the power 1 over 5 over 5th root of x cubed. First of all, and the best method to simplify such things is to change all nth roots into powers. So this will be written as x to the power 2 over 3 times x to the power 1 over 5 is already found, and this will be changed into x to the power 3 over 5. Now I have to multiply numbers or values having same basis but different exponents. So what should I do? I should add the exponents. In order to add 2 over 3 and 1 over 5, which are fractions, I have to make the same denominator. So here I multiplied by 3 up and down, and here I multiply by 5 up and down, so I will get x to the power 10 over 15 times x to the power 3 over 15, and finally I just add the exponents to get x power 13 over 15. And down, in order to subtract the exponents, also I change the power in the denominator also into the same into a power having the same denominator as above. So again, I multiply up and down by 3 to make the denominator 15 for this exponent. So I will get x power 13 over 15 over x power 9 over 15. Now I can subtract the powers. 13 minus 9 is 4 over 15, and by this I get the answer, that is x raised to a rational power. If I want to change it into a radical or an nth root, I write it as follows. The index is the denominator. I write it 15th root of x to the power 4. So always the denominator represents the index if I'm going to write it in the form of an nth root. Now the second example is x to the power 2 over 5 times 5th root of x to the power 8 over cube root of square root or radical of x to the power 12. X is positive. There is a condition that x is positive. Now, x to the power 2 over 5 is kept as it is. 5th root of x to the power a, as I told you, the index is always the denominator. So it is written x to the power 8 over 5. And downwards, what should I do? Let's see. Here, as if I have to, I can multiply the indices together. So I can put one sign like this one, radical, and I can multiply the indices. Here I have 2 because it's a radical, and here I have 3 because it's a cubic root. Then I will get a 6th root. So if I have an nth root of an mth root of x, I can write it as n times mth root of x. I can multiply the indices and put one radical sign. Okay? So let's continue. I have to add these exponents because I have the same base, and since they are of the same denominator, then directly I add them without changing. It is x to the power 10 over 5. And now 6th root of x power 12 is changed into x power 12 over 6, as I told you. The denominator is always the index that's outside. X power 10 over 5 is actually x to the power 2. And x power 12 over 6 is also x to the power 2, and by this the answer is 1 because I can simplify x power 2 with x power 2. And here is how to solve equations using nth roots. And this is the last idea in our chapter. If I have to find x, where x power 4 equals 81, then all what I should do is to get rid of power 4. So to get rid of power 4, I make a 4th root for the number after the equal sign. But since it is even index, I have to put plus or minus because any positive number has 2 4 roots. A negative one and a positive one. I change 81 into 3 to the power 4 and I will get x equals plus or minus 3. If I have x to the power 6 minus 64 equals to 0, I take 64 to the other side, then x power 6 equals to 64. It looks like this one. So I have to get rid of power 6, then all what I have to do is to make a 6th root for x to the power 6. It will be x, and for the other side, and surely I have to put a plus or a minus sign because the index is even. So I change 64 to 2 to the power 6 and finally cancel 6 with 6 to get x is equal to plus or minus 2. While x power 6 plus 64 equals to 0 has no solution in R. Why? because if I'm going to take 64 to the other side, then it is minus 64. And I don't have a number with an even power whose answer is negative. No number multiplied by itself 6 times, 6 even times, and the answer is negative. So this is undefined. This equation has no solution in the real numbers that are. Now what if I have an odd exponent like this? X power 3 equals 27. Then again I have to make a cubic root to get rid of power 3 in both sides, but I don't put here plus or minus, because in case of odd power everything is defined and only one cubic root exists. So x equals to cube root of 25, which is cube root of 27, sorry, which is cube root of 3 cubed, and the answer is 3. And finally, if I have x to the power 5 plus 32 equals to 0, all what I do is to get 32 to the other side, then x to the power 5 is minus 32. So I have to put a fifth root to get rid of power 5, then x is equal to fifth root of minus 32. Note that this is defined here because the index is odd, while if the index is even, for example 6 or 4, then this is not defined in R. Also, I change 32 into 2 power 5, and I will get, simplifying 5 by 5, I will get that x equals minus 2. And by this, we reached the end of our chapter, Powers of Real Numbers. Hope you enjoyed it, and inshallah, a lot of training exercises are going to be solved later to make you more familiar with that chapter.